All right, level 4 is kind of taking what we've learned here and apply properties or ideas of parallel lines and perpendicular lines. So you likely have seen this before. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So what I mean by that is, let's say, for example, a problem gave you an equation that had a slope of 2/5, okay? The parallel line's slope would also be 2/5, right? Parallel lines have the same slope, okay? They go up and over the same exact way. That's why they never run into each other. The perpendicular line's slope, opposite reciprocal, means you take the fact that this was a positive fraction, means it becomes negative, opposite sign, and then reciprocal means flip the fraction. So you're like flipping two things. You're flipping the sign and you flip the fraction. So your perpendicular slope would be negative 2/5. So the parallel slope to 2/5 is its same thing, 2/5. The perpendicular line is negative 5/2, okay? If the original one was negative, then the parallel one would be negative, and the perpendicular one now would be, the opposite of that would be positive, okay? See how that works? You've seen this before. All right. Line M, this question. Line M can be represented by the equation 3x plus 6y equals negative 4. Write each linear function below. So we want to write a function g of x. So again, that keeps in mind that we're going to write it with g of x. All right. Parallel to line M, and we're going to have a y-intercept of 5. Okay. So we need to know what slope is parallel to line M. Well, that means we need to know what slope line M has. So we need the slope for this equation. So how do we get slope for an equation? You get the form into slope-intercept form, and then the slope will be kind of visible there. So again, we want to get this equation in the slope-intercept form because we want to know its slope. Getting slope-intercept form means solve for y. So I'm going to subtract 3x over. You get 6y equals negative 3x minus 4. And you divide everything by 6. So really this equation is like saying y equals negative 1/2, you reduce, minus 2/3. All right? So what was the whole point of getting this equation? The whole point of getting this equation was so that we could figure out what its slope is. And its slope is negative 1/2. Cool. So that's what we really want. From all of this here, from all of this, all this work here, is we want to know what was the original equation's slope. Once we have that, we disregard anything else from here, right? Nothing else here is useful. We got the slope. That's what we were looking for. We know that this line or function that we want to draw now is parallel to this. So the slope we want is exactly negative 1/2. So we have the right slope. But I need a y-intercept of 5. So y-intercept is like 0, 5. Remember, 0, is y-intercept. And the nice thing about this is when you have a slope and a y-intercept, you can write this in slope-intercept form. Now, the question sometimes will say which form it wants it in. This one doesn't, so you can kind of pick whichever one you want. Slope-intercept form is the way I would go. So that's the y equals mx plus b. But we know an m. We know the m has to be our parallel slope, which is the same, negative 1/2. Then you still have to have the x there. Plus b, our b is our y-intercept, and we know that, that's 5. So this would be the equation of the line that is parallel to the original equation and has a y-intercept of 5, except it's not a function. So what do we got to do? We don't want y, we want g of x. I almost wrote f of x. Okay, be careful. Not that it would be a huge deal, but if the question says g of x, you should be writing g of x. Okay? And that's your answer. So your answer has to be in the form of g of x again. Remember? This is a slope that's parallel and has a y-intercept of 5. All right, next one. Write the linear function h of x, and we'll again write it in slope-intercept form, just for practice here. All right. It's perpendicular to line M, and it has this point right here. So perpendicular is where we start. We already have the slope from line M. Remember, line M's slope was negative 1/2, but that is not what we want, because we want our slope to be perpendicular to it. Perpendicular means opposite reciprocal. Change the sign from negative to positive and flip it. So it becomes positive 2 over 1, which is just positive 2. So the slope we have in our problem is positive 2. We have a slope of 2. We have a coordinate of negative 4, 6. That means point slope form. Why do we want to go to point slope form first? Because we don't have a y-intercept. This is not a y-intercept. The only reason we went to slope intercept form right away in that last one is because we had a y-intercept. So point slope form says y minus the y value equals the slope times x minus the x value, which in this case minus a negative 4 means plus 4. That would be slope intercept form. To get it, that would be point slope form, sorry. That would be point slope form. We want slope intercept form. I was reading but said the wrong thing. You want to distribute, get y minus 6 equals 2x plus 8. You add the 6 over. But again, we want a function h of x this time, so our answer needs to say h of x equals. You might say, why did you put it in slope intercept form? Because I kind of made that up, right? At the beginning there, I said I want it in slope intercept form. If I had just wanted point slope form, you could have left it like this, except you would have changed the y to h of x either way, okay? So perpendicular, opposite reciprocal slope, you need a slope, you do the opposite reciprocal, then you do the equation like we've been doing for this entire section.